It is red. Well, just go to Edumate Plus YouTube. Put on live. Again, it's but she can't ask questions. She can call me.
So you can check the chat box.
I don't have time. I get distracted while teaching. Yes. Shweta, what happened? You're not able to this thing? Hey, do me a favor. There is some new technology we are trying. Okay, I am streaming it on a YouTube channel, Edumate Plus. So just look at your this thing. The only thing you're not going to ask me any question, but at least today's lecture will go smoothly. There is no problem from my side, but maybe your data this thing is less. But we can have streaming it live. Just go to Edumate Plus YouTube channel. I am holding the phone, so you can. How will you know that she's? How will you know?
So you said we also like balance of sequence.
It works, yeah.
No, this is
Watching. Yeah. And maybe on that you can send a message. Shweta, are you? Are they? Huh? Link नहीं, just go to Edumate Plus. Live stream है ये. We were trying to do the live streaming from here, but he said it's an extra $50 per month. Already I'm worried about this. Then we worked out an idea. देखा आया लाइव स्ट्रीम That's it. नहीं आ रहा? हाँ? It's good. That's good. It will have latency.
Yeah.
It will have latency. Forget that. You'll not miss the lecture. Did you get the YouTube this thing? It is loading, huh? So what I'll do is I'll start the lecture. Okay. But this is not a very good idea because there's a latency and then you can't ask me any question. But today, because we are having problem, we'll continue like this. Okay? Now, listen. Then there is a huge latency. 30 seconds. Doesn't matter. We shall see the lecture. We have found a solution to that. So, state function. You can still address her. You know she knows.
Then you can off that if she's not going. If she's not going to join, you can off that.
No, but I know that things are going on. The latency, suppose we are talking something. I will come to know only after 30 minutes. So synchronization. So listen. So first thing is we are considering an extensive property. That's very important. Okay. Undergoing a change of state. The change is only dependent on initial and final steps. Suppose we take up property pressure. We know pressure of an enclosed gas is an extensive, and then we have volume. So at this position A, the gas has the pressure P1 and a volume V2. So I am going to bring it by this step to position B, pressure P2, V2. So this is path 1. I can do the same thing over here, bring it like this using path 2. So pressure and volume, which are extensive property, are also state of function. That means what? Their change is independent of the path. Their change is independent of the path. Are you understanding? Is it clear? Now what happens? What is the opposite? Suppose there could be an extensive property whose change is dependent on path. They are called as path variable. Or they are called as state variable. This is very important from the examination point of view. Why is it important from the examination point of view? Because they have this, which is not a state function. Which extensive property is not a state function? Some message. So which, Shweta, if you are on the live stream, if you have any problem, just give a call immediately. Okay, that's the best way for today. This is not a permanent idea. This is, we are saving the lecture. And we are trying a new technology. I mean, you are the guinea pig. We are trying to experiment. So we already did the last 3 days. I was not to do it today. So path variable or state variable. It's here. So path variable or state variable means what? Path variable or state variable. Example of a path variable, state variable is heat and work. See, heat. Now, heat absorbed and heat evolved. Both are not the same. Heat absorbed, we say Q is positive. Heat evolved, we say is negative. So, if we just say heat, it is not important. Heat is what? Heat is exchange of energy, flow of energy. So, you have to say whether the heat is absorbed from the system to surrounding or surrounding to system. So, you have to define the path. Just the word heat is incomplete. It's clear. Then one more thing which you will learn, it's called, I think, Mayer's equation. Heat and for a gas, mainly for a gas, because for a solid and a liquid, literally there is no change in the volume when heat is absorbed, because you have studied this in 11th standard physics. That is, you have alpha is equal to 2, beta is equal to 3 gamma, coefficient of cubical expansion. So when you supply heat to a solid or a liquid, the cubical expansion is not very high. But if you try that with a gas, volume expansion is very large. So you have to then say, is the exchange of energy taking place at constant pressure or at constant volume? Because that value will differ. Cp minus Cv is equal to R. For 1 mole, Cp is mean molar heat capacity at constant pressure. Cv is mean molar heat capacity at constant volume. Cp is greater than Cv. So there you just cannot say gas is absorbing heat. That statement of absorption of energy, that is heat, is incomplete. Why is it incomplete? Because you have not told the path, whether it is at constant pressure or at constant. Because heat absorbed or energy absorbed or flow of energy at constant pressure in the gas is not the same as at constant. So work. See, I have always been telling you that is cylinder, piston and all that, correct? So there are 2 types of work a cylinder and a piston will do. One is expansion, the other is compression. So you just say, you can't say the cylinder and piston are doing work. Work is an extensive property. But then you have to specify, is it work of expansion or work of compression? Because if it is work of compression, the direction of displacement of the piston and the applied force, the atmospheric pressure is on same side. So work of compression is positive. When you have work of expansion, the direction of displacement is on the upper side and the force, the opposing force is downwards. So work of expansion is negative and work of compression. So you have to tell initially, are you talking about work of expansion or are you talking about work of compression? This is clear. So these are path variables. This is clear. Once we come to path variable, this is clear. Then we have the next one. Okay. I'll wait for 5 minutes, Shweta. You take down this and then we can continue. Okay. And now we had You take down and then we'll continue. But it's a very temporary arrangement for you. Take down. How is that? Huh?
You can see how many people are watching.
Only one layer. People don't know. How do they know that there's a live stream going on? See, we are trying. What is this physics for? He also started with the live stream. So what we are planning is to go private. Have a lecture between 8 o'clock to 9 o'clock next year, starting February. No notes, no app, nothing. All India, 1500 is charged. But it will be every day 8 o'clock to 9. 6 days, 5 days. 6 days, 7 days, 7 days. Just try whether we can monetize. Do you think people will join? Only can.
Sure.
One watching correct time.
No, but including
This is a tricky idea. Actually. Maybe it's not counting. Shweta? Hello? Hello? There should be 2 watching, actually. But it's not counting. It will count you also. Are you hearing that in the live stream? Okay. Shall I continue now? Have you written down? Yeah. Okay, right on. See the next. I can't be here. For me, what is important? The lecture is not getting. And we are testing the technology. That is more. How many people are watching is not the point. We have an alternate technology. How do you know it's 30-second latency? What chapter is what is it? It's not no use to you. Why? Because I have given the record lecture. We are just trying to push element plus app.
Because in some way you have to make people aware that you're doing this.
Is it not? Here, ask her.
But how do you charge for people keeping it live?
Initially, for what we plan is, we will give it to only 134 students. Subscribe to our app in Maha. They are that COVID batch because the teacher published in. And I can understand they don't know anything because I've been Swayam Shetty over there. He can't add 10 raised to minus 5 plus 10 raised to minus 6. So I know if this is a city situation, inside knows it pretty worse. So those 134 people, money has been paid by Mahad Manufacturing. So we'll make it private fund. So we'll have 134 watching.
And then on YouTube, then you have to make it only big one.
I mean, I am not understanding the technology and I am.
in YouTube,
There's an
you
option.
can either make the video public so that everybody can watch it, or private.
You need to link it.
How do we make it? Right? This is the fourth day or fifth day when I'm this. You have to understand at 62, I'm learning the technology of stream. At your age now, you will do it in 5 minutes, everything. But for me, it is a step by step. So I'm testing the streaming, then how to go private, how to create the link. And then we need a special software of WhatsApp, which will, in one instance, send 600 to 1000 links to.
Podcast. It's
Yeah. Oh, shit. Last item. Finished? Great, great, great. But that's it. This is the problem that will happen, but will not, our lecture will not get cancelled. Okay, chap. And there is a lot of steps involved in between. There is a special YouTube software where WhatsApp software required, subscription software, where you put the link and you have list of WhatsApp numbers. Press the click. In 1 second it will flash. Otherwise, if suppose you get 600, 800 viewers, 134, 134 type करना क्या होता है? Lecture. So that. So we are doing one by one. You got it? You will be seeing the streaming part. So we were talking about what? Now we come to thermodynamic. Thermodynamic. Now we are talking about thermodynamic. It is clear. So now what we do is, I mean, this is not described. What is the thermodynamic equilibrium? If you look at the definition, a system is said to be in thermo when the state functions do not change with time. This is the only place, again, I told you, when, what do you call? There's a talk about time. Otherwise, there is no talk discussion of time at all in the complete chapter. So I write the definition, but explain what are the different equilibrium. That they are not explained. Clear? So a system is said to be. A system is said to be in thermodynamic equilibrium. System is said to be in thermodynamic equilibrium. Okay. When the state function is said to be in thermodynamic equilibrium, when the state function state function, that means extensive property whose change is independent of path. By saying that, this thing has become short. What do you call the definition? Is there the state function of the system okay, do not change with time. Do not change with time. Okay, just the definition is difficult to understand. Clear? So what we will do is we'll simply what you call take an example. What is the example we have? Suppose if I have a gas enclosed in a box. Gas enclosed in a box. Now suppose if the pressure of the gas does not change. Pressure remains constant. If the pressure is remaining constant, it's clear. Or pressure of the gas does not change. Then this is said to be in mechanical equilibrium. This is said to be in mechanical equilibrium. You can see over here now. Look at the example of this room, best example. There is air enclosed. Okay. We put on the AC, temperature has changed. We feel little very cold. Season is little. For some time, Bombay is cold. Okay. Otherwise, Bombay is never cold. Okay. The most polluted, no, we have a competitor. Delhi is more polluted than Bombay, which is clear. So no, she will not realize. Chitrapalli, she is very safe. No chemical industry, nothing. She comes from a real clean environment. God bless you. But then here, see, I'm in this room, there is air. Correct? What has happened? We may be changing the temperature, putting on the AC, putting on the AC and all that. But the pressure of the gas, the number of molecules hitting against the surface of container remains the same. So I can say that this gas, there is a gas, that is a system. We are looking at its extensive property, pressure, is constant with time. So throughout the lecture, imagine lecture, 1 hour, 1 hour, 15 minutes, the lecture, the pressure remains the same. The pressure remains the same. So what can I say? That the system is in mechanical equilibrium. The other possibility is what? Okay, when the temperature remains the same. When the temperature of gas remains the same, then we say the system is in thermal equilibrium. So here it's not possible. What is Nikita doing? Okay, I mean, I'm not blaming her. Even I feel cold. So when she feels cold, she just puts the AC off. Just clear. And AC switch is just above her head only. More convenient. So what happens immediately? The temperature rises. Then after she feels hot, again she is that in temperature. But suppose if you were to look at the server rooms, na? I mean, we are a software company, so we don't have a server room, but we use somebody else's server. In server room, there are two things which are very important. Dust-free environment, so you have HEPA filters first. Second is the temperature is maintained at 18. So people working in server rooms have to wear winter clothing inside. Why it is maintained at 18, you will ask? Because these servers are nothing but sort of desktop computers. They are giving out a lot of heat. And if so many computers at one time give out heat, one of the lead solders somewhere will melt. And what will happen? The whole thing will come to a stop. It is clear. So therefore, so that the heat is absorbed. So what is happening? There in a server room, what happens? The air in the server room is in thermal equilibrium. Temperature is not changing with time. They are maintaining the air conditioners at 18 degrees, 24 hours. So that is why you see what has happened to us. We'll tell you. We have this, which one? We have shifted. Scorer, please. One of the portals. It was in DigitalOcean. It's a Netherlands-based server company. What has happened to us? Two things. Double whammy. एक तो from $50 they have increased the server charges to 150 because electricity rate in Europe has increased. And then double whammy for me, what happened? $1 was 60 rupees has now become 83 rupees. So what was 4,000, 5,000 rupees server charges has now become per month. I'm talking per month. Okay, it has become $150. You got the point? So what we did, we shifted the whole code to Indian company. India electricity rate has not changed. It's clear. And Indian rupee cannot depreciate against itself. So we have shifted it to controlless, local fellow. Yeah. So it's a business decision. But this is what happens. Servers, they're kept at constant temperature. So their air in that room, if that is the system, we'll say it is in thermal. Give example, you'll never understand. The third one is we have chemical equilibrium. When the chemical composition the chemical composition, when the chemical composition of the system does not change with time, then we say the system is in chemical equilibrium. I can't say this about Bombay. Because here in this room, okay, in 1 hour I don't know that they bring some fellow, so the air wind will change, the garbage will bring in some more methane gas and some smelly gas. It happens. So in a day, very late in the night, the chemical composition of the air in the room changes. It is smelly in Bombay, horrible, God knows what poisonous gas it is. Morning may be a little different because there will be more of fog, water vapor will be more. So every time the chemical composition. So we say in Bombay, what happens? You are living in a house. That flat, that room does not have a chemical element because composition goes on changing. So you go to hill station, composition will not change. There it is in chemical equilibrium. So have you understood this? So textbooks don't mention about this, they just say this, but this is the logic. Take down. All this is there. But I have to take the train. 700 rupees per month is a subscription to WhatsApp, some scheme where just in 1 minute transmit the business. So that we have created, that we have tested. So we need 700 people or 134 people to have a test.
YouTube is a good idea because for you to start YouTube or watching YouTube, even the internet is less compared to watching it on that.
What is this? The quality of the transmission little less. We not realize. We are doing this transmission on high definition. That will be 740 pixels.
So for the students you have taken in my heart, but then it will be better because
Yes, that officer is correct. The download data is only hardly 1 Mbps now. Whereas here the download is nearly 3 to 5 Mbps. You got the point. That's why I said we are working on technology. We want to push it and bring an element customer.
the system is fully ready to start advertising on Instagram.
I mean, a lot of things we can. Yeah, I mean, very basic reports. We can have road. Like this is chunk. This is only scrap. We can have a road. This thing. We can have instead of video capture. We can have an ATM. Yeah, churches have excellent system. But abroad in America, churches have excellent systems. They are transmitting the prayer mass to people at home.
That's something that we made. You should have to do it to COVID.
Because of not the system. A lot of technologies. ATM mini, I think. So. Then we will need that sound card and mixer, but of a much of an American company, not this down-based crap. Actually, I need the consultant of a sound engineer. Here I am looking at YouTube and doing now my own experiment. If you have money and a sound engineer, this will get set in 5 minutes. Eventually, your goal is so if you are in Qatar also, I can send a YouTube.
That's a good thing what you do. You can translate it without problem like
No, you can say, except I think which country? China.
Not Korea.
Okay.
China also.
China is also.
China.
China has its own name.
Vivo, WeChat. Vivo, WeChat. Chalo. I'll just try to send her a message and see if that works. Are you finished? Is your phone call? Okay, see, this is another idea. Have you finished? Shweta, I've sent you a message. Have you finished? Moment you finish, put yes, I'll start teaching. What? Can't do difference. Can't work in wrong. Can't see that. Shall we start? Now listen. We are talking about process. Wait,
So she can pause in it also.
Huh?
She can pause in
This will be there in YouTube. So listen, now we are talking about types of process. So, types of process. So obviously you said new term is introduced. Just now I told you equilibrium. There is a thermal equilibrium. Temperature is remaining the same, or pressure is remaining the same, or the composition is remaining the same, number of moles is remaining the same, whatever it is. If you change any one of them, there is a change of state. But what path does it follow in that change of state? The path followed by a system. So the definite path followed by a system while undergoing a change of state, while undergoing a change of state, is called as process. So let's start with some process. First is we have isothermal process. So what happens? What is the definition of an, what happens? Why I'm writing like this is because it's a very popular question in any school. Differentiate between isothermal and adiabatic. This is clear. So what happens is, a process, first is the definition, a process in which temperature of the system, a process in which the temperature of system remains constant throughout, a process in which the temperature of the system remains constant throughout is called as isothermal process. Here. Now, how will the temperature remain constant? Only there's a free exchange of energy, no? Free exchange of energy. Actually, the boundary is what? The boundary is isothermal, allowing the exchange of energy from system to surrounding and vice versa. So the boundary is isothermal, allowing free exchange of energy from system to surrounding and vice versa. System to surrounding and we have vice versa. Is this clear? Then the third one that we have is, so what happens? See, if delta T, the change in temperature is 0, then delta U, the change in internal energy is 0. See, for a solid, internal energy is mc theta, depending on temperature. For a liquid, it is mc theta. For a gas, it is ncp delta T. N is number of moles, Cp is mean molar rate, capacity, and T is the temperature. Or if it is ncp delta T, if there is a change in, if there is no change in temperature, delta T is 0. So internal energy change will be 0. Internal energy is U. Change in internal energy is what? 0. It is clear. So internal energy will not change. It is clear. Then the fourth point is what? Yeah, this is all that is there. This becomes the fourth point. Now let us look at adiabatic. So what happens in adiabatic process? I told you when I was teaching the boundary. What is the boundary over here? It's a diathermic boundary. What does a diathermic boundary do? It does not allow the exchange of energy from system to surrounding and vice versa. So what is going to happen? Heat remains inside. There is no exchange of energy between system. A process in which there is no exchange of energy from system to surrounding and vice versa. System to surrounding and vice versa. Here, what happens? And vice versa is called what? Idea. Second point is boundary is diathermic. Your delta T is not going to be equal to 0. The temperature will rise. Adiabatic expansion, adiabatic cooling. I'll explain this. Then the fourth is what? Internal energy change is not equal to 0. That's clear. So take down this much. In the meanwhile, I'll just try to see if I can share after this. Download a picture of a bomb calendar. Now, all experiment will open a new. Help me out. I want to download a picture of bomb calorimeter. A picture of bomb calorimeter. Now, how do I download the? How do I show this?
Maybe show this on YouTube.
No, we showed in our mistake. Not me go to YouTube also. Okay.
Share something.
Huh?
So ma'am, show to the live stream, but that to the that, yeah.
This one, huh?
Yes, sir. Your
Yes, your transmission. Go to that three dots.
Share. 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 इधर है share video.
Share this
audio.
view. Yes, share this.
Screen share किधर है?
Share video, sir.
नहीं video नहीं.
Video.
Toggle. Screen share ना?
yes.
हाँ toggle screen share. Share.
Go to Windows, sir. Windows.
Chrome tab जाना पड़ेगा.
Chrome tab.
tab.
Or a picture of bomb category. Share.
Let me just check.
Or you can. Yes.
So now press the picture.
Which picture of
Oh, wow. Very good.
And then last.
So now click on the picture.
So is it getting shared?
Wait.
हाँ.
No, wait. No, no, sir. No, you go to the previous one. sir.
हाँ?
It's only that is the picture.
हाँ?
Sir, stop share. Stop share.
किधर shop share?
Just press that toggle to screen. Yeah, and also go to the third one, picture of not that one, sir. Yeah,
This one.
yeah. Select a picture and enlarge it. Not that one, sir. That's it.
It was fun. Yes.
This one, sir.
No, that one. We want it first.
No, that's a video.
So that's a video. So go.
Oh, I want a picture.
This one is okay.
हाँ चलेगा. हाँ.
Now you go to sleep into an
It's simplest take a long calendar. This is also more than.
Is it okay to see like this?
Ah, that's what.
Okay.
Ah, well. And how do we stop share? Toggle.
Just to go there and then.
You also can see now. Just take.
It will take some time to.
60 frame. Hey, yeah, I can use all bloody technology. Come on. Hmm?
Sir, are you sure that's seeing the screen or only the camera? Or if it
No, if we see the screen, we will know whether it is shared. Huh? Learning, wait. We have to. The screen में आ गया.
Sir, I think so. When you are showing it on YouTube, it's only this in the camera. It's not showing your screen.
हाँ. इधर share कैसे करते हैं?
हाँ sir, your is this okay?
This is prism. इधर कुछ होगा देख.
Your also you can share.
Share screen में. हाँ. देख share screen पे. ये अलग screen में. हाँ, इधर. Even ISO query process. That is share screen.
We keep it as a background.
No sources, for present sources plus
When
down
so
plus
that's the
नहीं sources.
then the
नहीं. Better. Sources.
image. Then you have to download it.
छोड़.
go to this one, go to where put that link of the image.
हाँ, मैंने पाया. इसको डाल. एक शिमिल में.
Go to down.
हाँ.
That image to copy the link.
हाँ. तो
Can't copy the information.
किसी का भी कॉपी माना जो कॉपी मास वी आर लर्निंग ना Yeah. Anything which will want, I just have to explain what copy is.
How do you extract now?
Hey, put that link. Okay. Have you got one? Put that on. There is a new prism which has happened. Escape. Now, okay. Yeah. Acha, leave it. Now I know I can't share in this, na?
Yeah. Normally you can share once. No, see it the camera. So wait, so it's not that.
Or you can have to download the image and share.
I asked
That's one thing.
It shows it. Huh?
Ah.
So you have to send your episode.
What?
You don't have to.
ठीक है. I'll ask Kaushik how to share in this. We'll see now. See, I know I have to learn one thing now. See, we have saved the lecture at least. Now I tell you. See, now what happens is, listen carefully. The next is, so you have, he must have taken down by this time. Now let's start the next one. The next is, I stop at that because then the next one we have is you know now what a bomb calorimeter is. Explain. So we have an isochoric process. This happens in an instrument called as bomb calorimeter. Why I am insisting and making so much effort to give you the diagram of bomb calorimeter is that in the numericals now they will say benzene was burnt in a bomb calorimeter. So you should know that they are talking about combustion in constant volume. If they just say benzene is vaporized, benzene is combusted, it is at constant pressure. But if they specifically say bomb calorimeter, then they may not mention its constant volume. They are telling you it's bomb calorimeter. So it's supposed to know that it is constant volume data. So bomb calorimeter, what happens? Isochoric process. The volume of the system remains the same. The volume of system remains the same. Is this point clear? That's an isochoric process. I'll stop here today because reversible and irreversible. It's clear. I have to teach what you call in a greater extent, and then we'll go over to first law. Next. Okay. Then after that, what do we have? Yes, straight away. Next time we'll start with first law, and probably to some extent we'll complete work also. Well, next time? Monday. Tuesday. And tomorrow 6 o'clock you will have lecture on first chapter, mole concept. Shall I stream it for you if you want? Mole concept. Law of conservation.
What time?
6 o'clock evening.
You're going to be mostly on the face.
You're going to be free.
You won't be free.
So what you can do is you can download the image
And
and
then
then
you
share the
can-
image.
Yeah.
Okay. problem is that stop the हाँ क्या बोलोगे?
Go to that
Picture. So 5 minutes we'll spend. हाँ. क्या कर देगा?
right click.
Right click. Download किधर है?
Save image. And then you save it. So
Save it anywhere with the name.
हाँ bomb करो next. Save.
and then open
So
the
go to Prism.
हाँ.
sources.
Sources.
किधर है?
So the second box. No.
Go to the
Top,
plus.
the plus sign.
हाँ plus.
And open image. Your image. And then okay. And okay. Sorry. Image file browse. And then desktop.
So you can save it on the desktop.
This is just some used to. किधर है? Where did you save it download?
So just go to this PC and just search for bomb calorimeter.
What was it?
Bomb calorimeter. Not in documents. In this PC. No, so just press this PC, the one on the left. And now just write bomb calorimeter. No, select file name.
इधर ना?
Select bomb and enter.
So it's okay. You might have not saved it. Just go to desktop and open it. Desktop. And open any of the
Open any image.
Just and then it comes.
So it has not got saved in the
Yeah,
desktop.
it's not saved.
One second, that's a don't.
हाँ open.
So press open. Okay. Now you can move it. And you can reduce it so that it can be on the side of the screen and you can explain it.
Yes, it's done.
Wow.